Next, we have to discuss about series. Here, first topic is that sum of first n terms of a series. The sum of the terms of a sequence is called a series. So, if a sequence is arithmetic or geometric, there are formulas to define the sum of the first n terms, denoted by Sn, without actually adding of all the terms. Note that a sequence can be neither arithmetic nor geometric, in which case you will need to add using brute force or some other strategy. Next, we have to discuss about sum of the terms of an arithmetic sequence, that is arithmetic series. To find the sum of the first n terms of an arithmetic, that is Sn is equal to n into a1 plus a2 divided by 2. Here n is the number of terms, a1 is the first term and an is the last term. Next, there is an example. Find the sum of the first 2020 terms of the arithmetic series. If a1 is equal to 5 and a20 is equal to 62. So here from equation s20 is equal to 20 into 5 plus 62 divided by 2. So s20 is equal to 670. Our next example is that find the sum of the first 4040 terms of the arithmetic sequence 2, 5, 8, 11, 14, etc. So here first find the 14th term. So here from equations a14 is equal to a1 plus n minus 1 into d. So that is equal to 2 plus 39 into 3. So that is equal to 119. So a14 is equal to a1 plus n minus 1 into d. That is 2 plus 39 into 3. So that is equal to 119. Then find the sum. So from equation Sn is equal to n into a1 plus an divided by 2. So s14 is equal to 14 into 2 plus 119 divided by 2. So that is 2420. Our next topic is that sum of the terms of a geometric sequence, that is geometric series. To find the sum of the first n terms of a geometric sequence, use the formula Sn is equal to a1 into 1 minus r whole raised to n divided by 1 minus r for r not equal to 1. Here n is the number of terms, a1 is the first term and r is the common ratio. There is an example. Find the sum of the first a terms of the geometric series if a1 is equal to 1 and r equal to 2. So from equation S8 is equal to 1 into 1 minus 2 raised to 8 divided by 1 minus 2. So that is equal to 255. Our next question is that find S10 of the geometric series 24 plus 12 plus 6 plus etc. plus. Okay. First find here r. Okay. So r is equal to r2 by r1. So that is equal to 12 by 24. That is equal to 1 by 2. Now find the sum. That is s20 is equal to 24 into 1 minus 1 by 2 whole raised to 10. So divided by 1 minus 1 by 2. That is equal to 3069 divided by 64. Our next topic is that arithmetic of number systems. Arithmetic operations in number systems are usually done in binary because designing of logic networks is much easier than decimal. Next, we have to discuss about binary system arithmetic. The basic arithmetic binary number system is binary addition. Binary subtraction is done by using ones or twos complements. Multiplication and division are discussed with shift registers in the later section. The addition of numbers in any numbering system is accomplished as in decimal system. That is, the addition starts in the least significant position, that is rightmost position, and any carriers are added in other positions to the left as it is done in the decimal system. So, the binary number system has 2 bits, 0 and 1 only. Therefore, the possible binary additions are 0 plus 0 is equal to 0, 0 plus 1 is equal to 1, 1 plus 0 is equal to 1, 1 plus 1 is equal to 0 with carry of 1. There is an example. Subtract octal number, that is 314 from octal number of 730. So here we have to minus the largest from least number. So 713 minus of 314. So that gives 377. Our next topic is that hexadecimal system arithmetic. There is an example. Perform a hexadecimal addition of C629 of hexadecimal number, and another number is that 9A52 of 16. So that gives C629 plus 9A52, that gives 1607. Start with the least significant digit column in the example. So add 2 with 9 and the table shows B as intersection point, that is number with no carry. Now add 5 with 2 from the table and the intersection points is 7 with no carry. Next step is that add A with 6 and the intersection point is 0 with 1 carry. Okay. Our next step is that sum can also be checked for correctness by the converting the numbers to their equivalent decimal numbers. Next, we have to discuss about compound interest formula. P into 1 plus R by 100 whole raised to n when money is compounded annually. Our next equation is that P into 1 plus R divided by 2 into 100 whole raised to 2n. This equation by using when money is compounded half yearly. Our next equation is that P into 1 plus R divided by 12 into 100 whole raised to 12n. This equation while using when money is compounded monthly. Next, if the interest is calculated on yearly basis, then equation becomes A is equal to P into 1 plus R divided by 100 whole raised to n, where A is the amount, P is the principal, and R is the rate per interest, n is the number of years. If the interest is calculated on half yearly, quarterly or monthly basis, the formula is A is equal to P into 1 plus R by 100k whole raised to nk. When compounded quarterly, amount is equal to P into 1 plus R by 4 divided by 100 whole raised to 4t. Present worth of principal P due t years, hence is given by P by 1 plus R divided by 100 whole raised to t. Also, A is equal to compound interest plus P, where P is the principal, R is the rate of interest, N is the time in years, and A is the amount, CI, that is the compound interest. Note that the formula A is equal to compound interest plus P will give us total amount. To get the compound interest only, we need to subtract the principal from the amount.